This is the extended version of the presentation on effective math services through the IEP. There are 5 elements of effective math services as I see it. Identify post-secondary setting, determine math multi-year scope and sequence and timeline, determine setting for math instruction, write IEP objectives that align with the multi-year scope and sequence and timeline, and useful progress monitoring. Let's start with identify post-secondary setting, which seems to be obvious, but from what I've seen, it's not. It seems that that IEP teams often focus on the near future without really taking into consideration the post-secondary setting. For example, I saw recently on a Facebook group a post about a student who was working on addition and subtraction for 2 years. The odds are that they're not going to get very far if that's how fast, that's the rate of progress. Also, I worked with a ninth grader who had been working on order of operations for an extended time. I have an example here of order of operations. And the family had hoped that he would have a chance of going to college. If he's working an extended amount of time on some simple operations, that really hampers his ability to be prepared for a college setting. So the first setting that I think about is having some sort of career, which would entail a 2 year or 4 year college degree. And then you would have math requirements associated with that. Second would be a vocation with specialized training that would have related math to that. And I will certainly get into all this shortly. And then the third would be a job that may have some math needs. For example, I worked with a family where the mom stated that her son likes sports and he may want to work in a sporting goods store. And so what occurred to me was in a sporting goods store, you may start talking sports, and there would be maybe some simple statistics to discuss, like the average number of yards per football game. And then the second element is determining the math scope and sequence, including a timeline. First, I want you to consider the following situation, which I've seen multiple times. A student is entering 6th grade and tests at a 4th grade level. So let's assume then, for argument's sake, that the student has mastered 3rd grade math. What that means is from kindergarten through 5th grade, which is 6 years, the student completed 4 years. That's an average of 0.66 grade levels per year, 2/3 of the math per year, which means if the student is to be prepared for high school, during middle school, 6 through 8, the student would need to complete those extra 2 years that were missing from elementary school. This means the student would have during middle school 5 math grade levels to cover in 3 years, which is an average of 1.66 grade levels per year. That's not going to happen. I also want to point out one thing. Grade level in math is not the same as grade level in reading. Math is much more of a web. There's a lot more moving parts. And for example, if you look at elementary school, especially third grade on, there's one, two, three, four, five different domains the student covers. So a fourth grade level could mean being at a second grade level for some of these, being at a fourth grade level for one or two of those, and then being at maybe a fifth grade or sixth grade level for a couple. So you have a wide range. Well, if a student's behind a number and operations in base 10, that's a significant gap as opposed to being behind in, let's say, geometry or measurement and data. So I talked about grade level, but that's just kind of a focal point for a broader situation that's much more complicated. So in when developing a math scope and sequence and timeline for career and college setting, post-secondary settings, the student needs to get to at least Algebra 1 in high school. So I have here an example. If a student wanted to go into nursing, the student would need to take Stats 215 or Stats 104. Well, for Stats 215, a prerequisite would be Math 102, which you see down here, and that involves an introduction to algebraic reasoning, which is very much has overlap with Algebra 1. You don't want the first algebra course that a student would have, especially a student with special needs, uh, to, to encounter algebra for the first time in college. This is an example of a scope and sequence and timeline that I created for a student. I create these for a lot of the students with whom I work. I built in seventh grade a flex year to really let the team stop and mull over the progress and think in sixth grade with this smaller number of topics, did the student complete enough that would lead the student to be able to get to Algebra 1 in high school? And then you see also that in the bottom here, I have Algebra 1 Part 1, which can be ambiguous and malleable. Uh, but the student would be in a general ed setting with special ed accommodations. But the student needs to experience uh, a lot more freedom, less of the support because they're not going to get that at college. I'll circle back to this in a little bit. Also, there is not just the math, but there is something what I call student skills, which is the ability of the student to be an independent learner to some extent. And I put on here basically a scope and sequence for those student skills. For vocation, it can be very dependent on the specific vocation targeted. Here's one for welding. If you look at this, the vast majority of the math is covered in elementary and middle school. The high school courses are much more academic and more related to college. And the algebra that you're solving is a lot of that is not going to be found in the vocations. There's another example, and this is for someone to be a plumber. And you can see here, similarly to the welding, you have measurement. This one has formulas, square root, angle measurements. And again, a lot of this is covered in elementary or middle school. And so if you have a student who has a post-secondary goal of work, even working in a car repair establishment, such as what this student had for a post-secondary career. There's not a lot of that specialized training at an institution that prepares plumbers or auto mechanics. This student might be working at the auto shop. This is the discussion I had with the parents. Uh, so the student would still need some math to be able to perform to some extent, but wouldn't be at the professional level, perhaps. I also have down here some of the mathy math, which what I call mathy math that would be related to this, but most of it is very specific, uh, like area volume. And then for a job, there could also be a specific type of math and also consumer or life skills math that may be not related to the job. And for this, they would be using a calculator. Uh, and the setting of this would be especially important in terms of what math there might be. And on the left, you have some of the consumer math, but on the right, for example, temperature is not a consumer math, it's more of a life skills math. And I worked with one student who had a vision impairment and and was at risk of slipping on ice. So we talked about looking at forecasts to identify when you might see ice on the ground. One extra point about this is money, where students and us in general are using bills and coins a lot less and paying with cards and now paying with apps. There's value in still counting money to understand the numbers you would see on your app and on your bank account. And so the student may still engage in that, but it may not be to prepare them to count out money to buy stuff. It would mean then to help them understand the concept of the decimal number that's associated with a price or value. And so I already referred to this. You have consumer math and life skills math. And the consumer math, I think, kind of overlaps with life skills, but you do have some life skills that are not consumer based, which I talked about earlier. Now let's look at the setting for the math instruction. So for college, you want the student to get at least 1 year in a math course that has a setting that mirrors college math settings in college. And in college, the student would only have 504 supports unless the college voluntarily added more supports. But most colleges that I've seen, and I've worked in several, that's not the case. And the idea again would be to include a focus on related student skills. In a vocation, we actually have some authentic settings built in if the high school has like wood shop or auto mechanics. And then this one's a little trickier when we talk about a job. If you look on the right, the student's counting out money on a table. Now, I've actually worked with students where I'm teaching them to count money, high school students, and you do have a big open space to spread out the bills when you're counting. But when you go into a grocery store, you're going to have to count money out from pulling it out of the wallet, which I've done, which I've seen with students that I've worked with in a like a grocery store, or they have the little check register that's a little small space. And then, so it's not like in the classroom where you have a big table, you have very little room to count out the money. Also, we at a school where I worked, we had a school coffee shop where students sold coffee to teachers, and they had to practice some of the social interaction, but they also had to run a register and take money and count money and give change as necessary. We also had at this restaurant a couple other settings to prepare students. We had an activity a couple times a year where the teacher, the special ed teacher, and I uh, were the workers. She was the waitress, I was the chef, although we didn't actually cook anything. Though I prepared the food, the paras would sit with the students and the students would order and would have to pay the money. We also had a grocery store where we had students practicing shopping and purchasing items. They didn't actually buy the items and take them with them, but it was the act of doing that. And then again, really focusing on real life situations. Now, I was able to take this student into a grocery store, and there are multiple situations that occur that we don't think about as adults because it becomes second nature. And I have a list here, and these are situations that came up with students I've taken to the grocery store. And there's the first thing I'd like to mention is the students aren't going to carry a calculator with them. They're going to use the calculator on their phone. So in the classroom, they should practice using a calculator on the phone and not a school calculator. They could practice counting the money on the counter, and you could see the picture on the left where that's what the student is doing. You also have comparing items based on brand or unit cost, expiration dates, tracking the total spending as you're going through and buying the items. And then again, kind of like the student skills, managing the cart and how do you wait in line and which register do you go to? Like, for example, I had some students that didn't understand that you go to a register or didn't know where the registers were or that some of the registers were closed. You also have a situation of problem solving where if a student has their list and they have a particular brand or particular size and they go to the shelf and that particular item is not there, now you got a problem solve. If you really need some, if you really need some cereal for your breakfast and your brand is not there, you could try to find one that's similar. So then we want the IEP objectives each year to align with that scope and sequence so that the student's not spinning their wheels for 2 years covering addition and subtraction, for example. Also, with the idea that the students are going to be behind almost all the time, the students we work with, where there is some triage to undertake to allow the students to progress towards their post-secondary setting. And there's plenty of math that can be cut out. So there should be a convergence also uh, of the math in a pull-out support class setting and then also in the classroom. What I recommend is that the support time, pull-out time, focus on prerequisites for the math that's covered in the general ed setting. Instead of having the general ed setting here, the math for that here, and then having the pull-out math be something different. I mean, if we have students that struggle with math and probably have math anxiety, giving them double the amount of math topics is probably not going to be effective. And so I kind of jumped ahead and talked about that here. Also, with IEP objectives, what I recommend is focusing on a unit or a chapter at a time and looking at the ultimate final type of math that they would do in that unit and make that the IEP objective. Progress through all the other topics in that unit, mastery of those would show progress towards the IEP objective, which would be at towards the end of the actual unit. And then I also recommend doing it sequential, going through the units throughout the year, and then you can have dates aligned with uh, those particular units. Now, in some states, perhaps that's not the way it's done, but you could still have an informal timeline like this with dates. And here's an example of what I did at a special ed school where I worked, where we actually had a sequence of dates. And again, so what happens is you're students working on solving two-step equations, and that's the focus for a month or two. And I've already mentioned this using a calculator. Um, But using a calculator for the calculations, and you can still focus on the concepts of addition and subtraction and multiplication without them having to do the mental math. So the concept is what's important, and then you're going to use a calculator, which is what a lot of adults do. Finally, looking useful progress monitoring. Again, useful progress monitoring is important. So I have here a progress monitoring data sheet that's on a Google sheet. I'm making this available. It would be in the video uh, description, and there would be a link, and then you can make a copy and actually use it. So there's four elements of useful progress monitoring. First of all, it needs to be meaningful math. Second, it needs to be actionable. So for example, in this particular situation, the student only got one problem right out of four. And so obviously there's some work that needs to be done there. The data shows you, instead of a more informal student is doing well, you have some actual data. So you click on this, you click on that, you see how it has a link. And this is a PDF that actually shows the student work. And you could start to identify where the student's messing up. Maybe they get some of the problem correct, but there's some parts that they're struggling with, and knowing that would make the data actionable. It's also progressive, like I'd mentioned earlier. What I do is a task analysis where the last step of this task analysis is the IEP objective, but all these other steps towards that task and that final, uh, as I mentioned earlier, that all these steps towards that final IEP objective can show you progress or the lack of progress. And finally, this allows the team to have cohesion because you can share this with parents and anyone else, and everyone kind of knows what the data is and the progress is, and that it allows the team to pull together, again, without relying on simply telling the parents the student's doing well. So again, I'll make this presentation available as well. And if you click on the example, this actual Google Sheets document pulls up. And again, I'll put that in the YouTube description for this video. So in this video, we covered 5 elements of effective math services: identify the post-secondary setting, determine math scope and sequence, determine the setting for the math instruction, write IEP objectives that align with scope and sequence and timeline, and useful progress monitoring. So I hope this was useful for you. I hope this will help you to help the students that you are supporting.